Assalamu alaikum. Today we are going to discuss the lecture 4 of DSP. The contents of lecture 4 are discrete Fourier transform, inverse discrete Fourier transform, time domain to frequency domain and frequency domain to time domain, discrete Fourier series, periodic and non-periodic, sampling rate, maximum frequency and the comparisons. Discrete Fourier transform. In digital domain, the range of discrete Fourier transform is 0 to pi, and we have the formula x of k is equal to summation from 0 to n minus 1. X of n is equal to e raised to the power minus j 2 pi k n over n, where the k ranges from 0 to n minus 1. We consider the periodic signals in DSP. If we have the periodic signal, we have discrete Fourier series, and when we have the non-periodic signal, we use discrete Fourier transform. In discrete Fourier series, we have Ck is equal to 1 over t integration of x of t into minus j k t omega naught, where omega naught is equal to 2 pi f naught and t naught is equal to nt. Nt is the number of samples. We have the same formula Ck is equal to 1 over n summation from 0 to n minus 1 x of n e to the power minus j 2 pi k n. Internal transition of the system remain the same. Let's do an example. We have the x of n is equal to 1, 3, 0 and 2. We have to find x of 0, x of 1, x of 2 and x of 3. By putting the values in the formula, we can obtain the following values. X of 1 is equal to 6, x of 0 is equal to 6, x of 1 is equal to 1 minus j, x of 2 is equal to minus 4 and x of 3 is equal to 1 plus j. You can also observe that after the highest sampling rate, the next value is the conjugate of the previous one. Inverse discrete Fourier transform. The formula of inverse discrete Fourier transform is x of n is equal to 1 over n summation of k is equal to 0 from n 0 to n minus 1. X of k is equal to e j to k n over n. We have two signals. Signal 1 is given as 0, 1 minus j, minus 4 and 1 plus j, and the second signal is 6, 1 minus j, 0 and 1 plus j. Now we find x of n for the both signals. For the first signal, we have the following answers. X of n is equal to minus 0 0.5, 1.5, minus 1.5 and 0.5. And for the second, we have x of n is equal to 2, 2, 1 and 1. First transition has more fluctuations while the second transition has less fluctuations. In the given data, we have n number of samples, which means 8 number of samples. 8 is the maximum. When we calculate the Fourier transform of the given data, after getting the highest value, which is maximum value, that is 8, we have the next values as conjugate of the previous values. As you can see, x of 3 is equal to 6 minus 6.82 plus 2.82j, and after the maximum point, x of 5 is equal to 6.82 minus 2.82j, which is the conjugate of x of 3. Similarly, you can see it for x of 6 and x of 2 and x of 1 and x of 7.